welcome back to the class. Welcome back to the session of states of matter. And I hope you all are good. How are you all? You'll say, ma'am, first of all, you are saying, how are you all? And then, no, first of all, you are saying that I hope you all are good. And then you are asking that, how are you all? Okay, so it happens sometime with everyone. So ignore it. So yes, student, what the thing is that in the last session, or if you have watched the last video, so I hope you get to know that what's the state of matter is, that what exactly we call it as the matter. And even the student, like we have discussed so many examples, so many experiments, not so many, but it's just that two or three we have discussed. But so that you'll come to know that what's the matter is, what are the characteristics of the matter is, or like what we can say that to say something as a matter, what should be the requirements, okay, that what should be the conditions. So we have seen all of these things. Like if I ask you that what's the particular definition of the matter, so you will say that, ma'am, matter is something which occupies space and have some mass, so that's the condition to say anything as a matter. Exactly, student, if you remember. And what we come to know that the matters are like the matter is made up of the particles. That means it contains particles which are very tiny, in nature. Exactly, they are very very small, that even though you can't look them with your naked eyes. So that's the particles, and you can say that the particles are there and they have a space between them. So that if you remember one of the example of the salt solution which we have discussed, that there is the beaker in which we have taken the water and it is having the space between them, so that salt is dissolving in it. Exactly. And even though the level of the water was not changing, so that's the point, student, we have come to know about the matter and their characteristics as well. Now my dear students, so like starting in today's session, we are continuing with this chapter only, that's the states of matter, because it contains so many things which you have to learn. Okay, so students, we are going to discuss all of these topics today, like what's the classification of matter, even though in the last session I have just give you a very, very little introduction about it, that yes, students, we are having three states of matter: solid, liquid, and gases. But how they are differing from each other, what are their properties, or how we'll say that it is solid, liquid, or gas. So we see all of these things in today's class. Fine. But students, like you'll say, mom, oh my god, we are going to discuss so many topics right now. But my dear student, it's just that they are very simple. It's just that you have to focus on one of the factor, and that's how you will do each and every type of question over it. It is one of the easiest chapter. Like even though when we have started this chapter, I have already told you that this is easiest chapter. You'll come like you'll come to know when we are going to complete it. Okay, because it's just that what's the solid, what's the liquid, and what's the gas, and these all are the points are also very easy. It's not like that you have to focus very thing so much, or it's like that they are having very heavy numericals. No, nothing is there. It's just that you have to focus only one point, and then you will be expert in this chapter. And even though you can teach this chapter to me, so that's how you are going to be very perfect in this chapter, because this is very simple. Okay, so my dear students, starting with today's session, and yes, I want you all to watch this video or to watch this session very carefully, very attentively, so that you'll come to know each and every point. Okay, so yeah, starting with the session. So first of all, student, like how the classification of matter has been done. So my dear student, classification of matter, if I see that there is the three classification they have made, it is the solid first, then it is the liquid, and then it is the we can say that the gases can also be there, or you can say in the form of the vapors also. So these are the three states of matter which we get. One is the solid, liquid, gases, and vapors. Now you'll say, ma'am, that how we define that, okay, it is the solid, it is the liquid. So these all depends upon the properties, student, that the properties which we are getting, on that basis we'll say that, okay, this one particular is a solid, this is liquid, and this is gaseous and vapors. Okay, but as my dear student, this is a very new thing for you. So we have one very very simple example. Like even in whenever I teach this chapter to my students or something like that, I always use this that example, because it is the one of the easiest one, from which you will come to know like solid, liquid, and gases state of matter and the difference between all of these. Okay, so now if I give you one example here, that's the water which we drink. So it is what it is, liquid in nature. Exactly what we call it as the liquid. The substance which is having the ability to flow, we call it as the liquid. Exactly, student. Like if there is the water, so water is having the ability to flow. You can't resist the like the flow fluidity. That property is also called as the fluidity. If any material, oh sorry, if any states of matter that the liquid is having the ability to flow, so we call it as the property as the fluidity. That means this particular state of matter is fluid in nature. That means it can flow easily. So water is a liquid because it can flow. Fine. Now, student, if I heat up this one or if I boil this water, so what I'll get vapors from it. So this is the state of matter, like boiling of the water give us vapors. Even though if I ask you to take one pen and pour some water in it and heat it, so after some time, what you will see that there are the vapors formation. Exactly. So that's the vapor, student. Now you'll say, ma'am, what's the gases? So, my dear students, like if we talk about oxygen, carbon dioxide, and everything, like if you know that for the respiration process, I hope you all know this thing, that oxygen we use for inhale and the carbon dioxide we use that to exhale. That's how the respiration process works. Exactly. But students, gases are those type things that you can't see them very clearly with your naked eyes. For example, students, if I say that I'm inhaling carbon dioxide, so like am I able to see that carbon dioxide, that okay, this dioxide is going inside me, or the oxygen not sorry, what I'm saying here, carbon dioxide is coming out and the oxygen is going inside. Exactly. So will I able to see that oxygen is coming inside and carbon dioxide is going outside? Exactly, no. Because student, gases are not visible. That's why the atmosphere we are having so many gases in it, but we can't see them. But it's just that this is the third state of matter, and why we have included here, we'll see that. Okay. On the basis of their properties, so that the water vapor. Now, student, if I freeze this water, okay, if I freeze this water, so what I'll get ice. Okay, that's the, you know na, that when we freeze the water, so we'll get ice, and that ice is the solid form, student. Okay, so that's the thing, student, that the classification of matter has been done, that is the solid, liquid, gases. Okay, now we are going to study the properties of each of them one by one, that what is the particular property of solid, liquid, and gases, and how we are differing them, that how they are different from each other. Fine. Okay, it's a very interesting one, students. Fine. So first of all, we'll discuss about the solids. So, my dear students, like in your from your last session, if you remember that I have already told you that the matter is made up of the particles, that is the tiny particles. So, in the case of the solid, student, what happened? The particles which are present in the solids, they are very compactly packed. Like in this structure, you can see that these blue dots representing the particles, and you can see that they don't have any space between them. They are just like compactly packed, very closely packed with each other. For example, if this is the one particle, so the another particle is just compactly packed with each other, they will not have any space between them. Okay, so like if I draw one like here, so it is like this thing, like this. You can say that they have a space, but that space is negligible, like it is very, very, very less, it is very negligible. So that is why, student, these all particles, you can see when they are such tightly packed, so these particles not having any space to move here and there. Exactly. That is why, student, we call it as the solid, because the particles which is present in the solid, they are very closely packed, very tightly packed. That means they do not find any of the space to move here and there. So now on the basis of that, student, we'll see the properties of solid. Okay. So yes, solid particles are very tightly packed, closely packed. And even though they don't have any gaps between them, like they are very, if there is any gaps, it is very negligible. Fine. And students, like if I talk you about the compressibility, do you know what's the compressibility is? So, student, compressibility is like the sponge. We have sponge, and if I try to press it, so what will happen? That the sponge will change its shape because I am applying the pressure, and due to that pressure, the shape of that sponge is going to be changed. That means that a sponge is the compressible in nature. That means I can compress it. Okay, but In the case of the solid, what happens, student, that the particles are so closely packed or they don't have any space. If I try to compress that solid, I will not be able to compress it because they do not find any space to move here and there. That is why, student, that the solids are not compressible in nature. That means they are very tough to compressible. So we can say that they are very less compressible. Okay, but yeah, if you're giving very high pressure, like very high pressure, then it can compress. But if you are just applying with your hand or something like that, so it is not going to be compressed. For example, student, if I take the example of this pen only, this pen is so small. I'm not talking about any iron box or any bed or any door which are solid in nature, because they all are solid. Exactly, I'm not talking about them. I'm just taking the simple example. If I try to compress this pen, so will I able to compress it? No, because all of the particles are so tightly packed, they don't have any space that they can move from here and there. That is why, student, the solids are very less compressible, or you can say that it is very tough to compress the solid. Okay, now, student, as the third point says, solid has a fixed shape and volume. Now, my dear students, why we are saying it as having the fixed shape and volume? See, this pen is having this fixed shape. If I try to compress it and if I try to like apply my force over it, so what will happen? It is not going to change its shape at any cost. Exactly, at any cost, it is not going to change its shape. Even though, student, if there is one iron box and I ask you to put that iron box into a very small space, for example, the iron box is this much and the space you are having this much, so will you able to to put that iron box there? No, because it is not of that space. Because solids are having their fixed shape and volume, that you can't push it and you can't fix that iron box into that particular space because it is smaller. And whereas the space of that, or the you can say that the volume of that iron box is more, so that's how you can't do it, because the solids are not having the like they don't have the property to get compressed. Exactly. So that is why, student, solids are always having fixed shape and volume. And due to this only, student, they are very rigid in nature. Rigid means that the particles are not able to move here and there. For example, student, like if I hit this pen, I am able to hear that noise. But will I see that this pen is going to be break down or there will be some powder formed? No, exactly no. Why, student? Because the particles in the case of the solid, they don't find any space to move, so they just vibrate at their position, that at their mean position means at the position where they are present, so they just vibrate at that particular position because they are not able to move. Okay, they can't move. So that is why they are rigid in nature. They can't flow. What you can say, that the rigid is the opposite of the fluidity. That the fluid means that with the material or substance which can flow, but the rigid one is that which do not flow. That means, so the solids are rigid in nature. Fine, students. Now coming to the next point, that about the rate of diffusion, that the rate of the diffusion in solid is very low. Now, student, what's the diffusion means? Diffusion means when two things or two or more things combine with each other, diffuse in each other and form some kind of mixture. That is the diffusion. Okay, now this is my hand, this is also solid, this is a pen which is also a solid, not solid. So when this pen, if I try to like diffuse this pen in my hand, like I'm doing this much, like I'm trying a very high pressure force, even though this pen can't diffuse in my hand. So what we can say, that the solids are having like solid and solid diffusion, the rate of diffusion is very low. Because, students, like again there will be the same point, there will be no any such difference. The reason behind each and everything is that the solids are having very closely packed structure, that the particles are very closely packed, very tightly packed, due to which they don't find any space, and that is why they have fixed shape, they are rigid in nature, their rate of diffusion is very low, because this pen will not find any space to move here. Exactly, if there is some hole and try to put my pen there, so obviously it will go there because there is the space. But here, this my hand is not having any space, so how it can go there? Exactly. So the rate of the diffusion in the case of solid is very low, students. So that's how, student, these are the properties of the solid which we have discussed till now. And if you see that all of the reasons, like all of the properties, depends upon only one reason. It's just that the solids are very tightly packed and very close, and like you can say that the particles are very close to each other, and that's how they are very less compressible. Okay, so that's the point about the solid. So these all are the properties of solid which we have discussed till now. Now, my students, my dear, very dear students, we are going to discuss some classification of solids. That the solids are classified into different type of solids. Okay, see, so we are having four type of solid. First is the molecular solid, second ionic solid, third metallic solid, fourth covalent solid. Now we'll see that how they differ from each other. Okay, so my dear students, like in your next chapter, you are going to see that what is the molecule, what is the atom, or you are going to study all of these things. But it just, student, if I want to tell you that what is the molecular solid, so just remember this thing right now, that the molecular solid is that type of solid which contains molecules, and the molecules are those which formed by the combination of the atoms. Atoms means, students, whether if we are having any of the atom like hydrogen, chlorine, and I hope you have heard or like hydrogen, chlorine and everything in your small grades also, but it's just that you haven't heard more about them. Okay, so when atoms combine with each other, we get molecular solid. For example, student, if I show you one picture here, that it is the carbon dioxide, this is the iodine. So these two that these are combining with each other. So it is the I and I, it is forming the I2, and I2 is a molecule because I is the iodine, which is an atom, and this atom combining together and forming a molecule. So that's why, student, the structure of the solid which are we getting on the basis of the molecules, we call it as the molecular solids. Okay, so this is the molecular solid, students. Now, if we talk about ionic solid, so you will say, ma'am, what's the ionic solid is? So, my dear students, ionic solids are those type of solids. If you remember the cation and anion, which you have just discussed in your class 8, so the solids which are having the cations and anions, so we call them as the ionic solids. For example, student, if I take the very common example, that is the sodium chloride. Sodium chloride is NaCl, which we call it as the common salt also. It is also known as the common salt. So in this case, student, what happened, that this is the Na ion, that in this case what we can see that it present in the form of the Na positive and Cl negative. Exactly, one is the cation and one is the anion, and they are arranged in such a manner that one of them is containing the Na positive, then another one contains the Cl negative, then it is Na positive, and then again it is the Cl negative. So such type of solids which are made up of the cation and anion, we call them as the ionic solids. Okay, so first is the molecular solids, in which we get from the molecules. That means they are either of the same nature. Okay, for example, iodine, carbon dioxide. So these are the molecular solids in which we are not having any ions, but in the case of ionic solid, we get in the form of the ions only. Fine. Now, if we talk about metallic solid, you will say, ma'am, what's a metallic solid? So from this name, you can easily remind metals. What are the metals? For example, iron is there, aluminium is there. So my dear student, the iron sheets or the aluminium sheets which we are getting in our houses to do like for any purpose, for use of any purpose, so such type of solid which just have the iron atom or the copper atom, and they form the solid, so we call them as the metallic solid. For example, if I show you right now here, so that my students have the clarity about it. So yeah, what we were discussing, metallic, which comprise of only one metal atom. For example, student, if I talk about iron box or the iron sheet, if I talk about that, I am having any iron sheet. So what happens, student? Iron is representing by Fe. Okay, Fe is the symbol of iron. So what happened, that all of the particles which we are having, they are having only iron and iron in it. There will be no any other type of atom present in it. So the solid which are made up of the metal atom only. So we call them as the that as the metallic solids. Fine. Now you'll okay, so the last one is the covalent solids. Now you will see, ma'am, what's the covalent solid is. So my dear students, like you haven't studied about the bonding formation till now. So the for the covalent solid, it's just that you should know in this type of the solids we get a giant type of structure. For example, diamond is there. So these type of solids like diamonds, or we can say that one is the diamond, and another one is also there, and I'm forgetting that name. So just take the example of diamond. So in this case, what happened that they combine with like the atom, they will have the same type of atom, they will have covalent bond in that. You'll learn to know that what's the covalent bond in that. In that case, what happened na, that there is the sharing of electrons. Now you'll say, ma'am, what is the electron and everything you are talking about? Okay, so it's just that just remember this thing, that the covalent solids are a giant molecule structure. For example, diamond. Okay, if I write down here that what is the covalent solids. Okay, I'll write down again so that my student will understand it clearly. Fine. So it's like covalent solids which are having a giant structure. They are very strong in nature. For example, diamond, and due to which student we can say that they are very strong diamonds. So due to which we that they are having high melting point and boiling point, because to melt something we require that it should be like very soft so that it can melt easily. Exactly, but the diamond is very strong in nature, due to which we get very high melting point and the boiling point for the diamond. So these are the four type of solids which we have to discuss right now. Okay, so just remember molecular solid, which are made up of molecules, ionic solid which contains the ions, metallic solid which contains only metal atom, covalent solid, you just remember that they are the giant type of structure they form. For example, a diamond which is very strong in nature because of very strong force of attraction, you can say that, due to a very big molecule formed. Okay, so that's the classification of solid. So students, what we have discussed till now, we have discussed what are the properties of solids and the classification of solid. Fine, and I hope you are getting everything right now and I'm not making you bored. Exactly. Okay, now properties of solid, student. Like in this case, you can see, like if you compare this picture from the picture of the solid in which particles are very tightly packed with each other. In the case of liquid, what you can see that this is the water, and they have just zoom it so that you can clearly visible the particles of the water, that how the particles of the water exactly arranged. So my dear students, you can see that in the case of the liquids, that the particles are not that much closely packed as compared to the solid. In the solid, what's the case, that the particles are very tightly packed, that they are so best friends with each other that they don't want to leave, that they don't want to make space between them. But when we talk about the liquid, so this is the thing, that one particle is there, so the another particle will there, and that's how they will have some space between them. They are not that much closely packed as compared to the solid. Okay, and even though I have already told you what are the liquids, so the liquids are those type of state, the state of matter in which they are fluid, that means they are having the fluidity, that means they can flow easily. Okay, so yeah, now discussing about its properties. So the liquid state of matter, particles are less tightly packed as compared to solid. Exactly, when we have seen for the solid, so it's just that the particles are very close. But in the liquids, the particles are not that much close to each other, and even though not that much like packed with each other. Okay, now if we talk about their shape. See, student, if I'm having one glass of water and I pour that glass of water into one bucket, so what will happen? That water will occupy the shape, or you can say that it will take the shape of the bucket only. So that is why, student, we say that thing, that the liquids do not have any fixed shape or volume, because they can transfer from here to there exactly. So they don't have any fixed shape and volume. The container or any box which you take to keep that liquid, so what will happen, they will take the shape of that particular container only. For example, if I am taking water in glass, or in any mug, or in any utensil, that is a big utensil, or in bucket, so they will occupy the shape of that only. So that is why liquid do not have any definite shape and even the definite volume. Okay, now students, what will say about their compressibility? Like in the case of the solid, there were no spaces, that's why they are very less compressible. But if we talk about liquid students, so what we can say that they have space between them. So that is why we can say that liquids are difficult to compress, but it's not like that they are very less compressible as compared to solid. They are compressible. Okay, as liquid are difficult to compress, as particles have less space between them to move. Yes, there is less space, but you can compress them as compared to solid thing. Okay, for example, water, you can't compress it easily. So yes, that's the difficult thing. But as compared to solid, if we talk about, yes, they are somewhat compressible as compared to solid one. Okay, so that's the property of liquid. Now, if we talk about what is the force of attraction between the particle, like student, in the case of the solid, the particles are very closely packed to each other, due to which we say that the force of attraction is very much there. Okay, but in the case of the particles of the liquid, they are not that much close to each other. That is why student, the force of attraction between the particles is less. Fine. And now if we talk about the rate of diffusion, so my dear students, if I talk about again the salt solution, so the water is having the space, and the water can like water is one of that thing in which we can dissolve anything, not anything but most of the things. For example, salt, sugar, even though sand is that it is not completely soluble, but what will happen na, that the water will get dirty. So that means we can say that dirtiness is going to be dissolved in the water. So that is why student, in the case of the like if we talk about the liquid, so they are, the rate of the diffusion in the case of the liquid is higher as compared to the solid. That in the case of the solid it was very low, but if we talk about the liquid, so they, yes, they are having, you can say that yes, they are having high rate of diffusion as compared to solids. Fine, students, so these are the properties of liquid. Okay, so these are the properties of liquid. Now, what you can say that the solids are having more force of attraction, but the liquids are having the less force of attraction between their particles. So that is why solids are rigid in nature, but the liquids are fluid in nature, because they are having the ability to flow. Because what will happen that their particles are having space, so they can move here and there. But in the case of the solids, the particles are compactly packed. They don't have space like there. So that is why student, they are rigid in nature. That means they just vibrate at their position. They will not allow to move here and there. Exactly. So these are the properties of liquid. Okay, now coming to the properties of gas, that what's the gases. Now, student, if you see that the gas is in the form of the bubble they have shown you here, and the particles are very, like very what I can say, very far away from each other as compared to solid, as compared to liquid, the particles are very far away. So that, student, we can say that in the case of the gases, the particles are very, very less like you can say that tightly packed, or you can say that the force of attraction between the particles of the gases is very less, like very weaker than liquid. So that's the thing, students. That is why that they are very far apart from each other in the case of the particles of gas. Even though the force of attraction is very less, you can say that negligible, that they can move freely. That is why you can say that in the whole of the atmosphere there are only gases and gases, because the particles can move here and there, so that we are getting they like oxygen everywhere. Exactly, like if I'm sitting in this room, I'm getting oxygen. If I'll go out, so I'll get oxygen, because oxygen is everywhere, because the gases particles are freely to move. Okay, it's not like that na, that I'm going somewhere and I'm not getting oxygen over there. It is that everywhere is the gas, because they are freely movable. Fine. Now, if we talk about their volume and shape. So, my dear students, like if I'm taking one like cylinder or any of the container, and if I fill the gas into it, okay, so that gas particles will occupy all of these spaces. So that is how, student, gas can occupy, or gas can take the shape of any of the container in which you are taking it. Okay, for example, if we talk about the atmosphere, so they don't have any, like atmosphere is there, atmosphere is not like any container. So that's how they there, and the gases are present there. So that's why, student, gases do not have any fixed volume or the fixed shape. Fine. Now, if we talk about the compressibility, so my dear student, have you heard about the like LPG? that is the liquefied petroleum gas. So yes, student, it is just because that the gases particles are very far apart from each other. Like one is there, and that's how they are very far apart from each other. And when we put any of the pressure over there, so what will happen, that the particles will try to come closer to each other, and due to which we can say that the gaseous state is highest compressibility, that they have the highest compressibility, because we find so much space between their particles, so that if we try to compress it, so that particles can move close to each other, and that's how they can compress. And after the compressibility, student, what we can get either the solid form or the liquid form. Because what will happen, student, if the particles will come closer, so what's the property of the liquid, that the particles are closer to each other, but yes, they have space between it. And if I try to compress it more, so they will come very close to each other, in which they don't have any space, and that's how we get solid. Okay, so that's the point about the gas. If someone asks you that which of the state of matter is having the highest compressibility, so it's that it is the gas which shows the highest compressibility. Fine, students. So that's the point about the compressibility. And even though like they on compressing, like I have told you, if the gases particles are very far apart, if you try to compress it, they will come close to each other. And when they come to close each other, it is the property of liquid state of matter, they will convert into the liquid. And if you try to compress it more, so they will come more closer to each other, and that's how you will find out the solid state of matter. So that's the property of gas. Okay, now if we talk about rate of diffusion, so my dear student, the rate of diffusion of gas is very very high. How? For example, again we can take the example of oxygen, that the oxygen is everywhere. It's not like that you are getting oxygen in one particular room or in one particular area. Wherever you are going, there is oxygen, there is all of the gases. Why? Because they are having the property of diffusion. What's the property of diffusion, student? Because their particles are very far apart from each other, and they have so many spaces between them, so that other particles can enter into it. Exactly. For example, if we talk about the deodorant smell, if you remember, I have given you one that example also, that if you are applying the deodorant and you are in one of the room and you are going somewhere else, and that's how the same person will come to know that yes, you have applied the deodorant, and he will ask you that like, have you applied the deodorant, or which is that deodorant, it's smelling very nice. From what process? Because the deodorant is, the smell of the deodorant is going to be diffused into the atmosphere, into the like gaseous particles, and that's how he's able to smell that gas. So that's why, student, the rate of diffusion in the case of the gas is very high as compared to solid as well as the liquid. So these are the properties of gases, students, and I hope you are getting all of these things. Fine. Now my dear students, I want to discuss one important point here. Or you want to complete diffusion? We'll see diffusion later. Okay, just give me one like. See, particles are very small. They are not that much big. They are very, very small. It's just that to make you understand, I am drawing it very large. Okay. So if someone asks you that what's the size of particles, so don't show it that my ma'am drew it like a circle. It's just for your understanding. Particles are very tiny in nature. Okay. Okay, so these are the three beakers in which we are having, like you can see that these are the particles. Oh, okay. Or what I can do is that these are the, okay, this is the condition. Fine. Or I can draw it. Oh my God. Okay, so just give me a minute so that I can fill this box now. Don't like ignore these spaces. You'll say, ma'am, you were saying that there will be no space. Okay, so I'll fill that space. Don't worry. Okay, so these are the three conditions in which you can find out that in the first condition, the particles, these, okay, this represent the particle. Okay, the particles are very close to each other. Exactly. If the particles are very close to each other, so what the stated, it is the solid. Particles are close to each other, but yes, they have space between it, so it is the liquid one. particles are very far apart from each other. That is why it is the gases one, the gaseous one. So these are the three state of nature, student. Fine. Now there are the, like, we have studied about rate of diffusion, we have talked about compressibility, we have talked about like what I can say, volume as well. So my dear student, like if I apply the pressure over here, so what will happen? These will particles will come closer to each other, and that's how the gas is having the compressibility. But we have two more things. Okay. So first of all, it is the temperature and the kinetic energy. Now, my dear students, what's the kinetic energy is? Kinetic energy is that type of energy which develops when something is in motion. When something is moving, then we call that energy as the kinetic energy. Okay. So if I ask you that which of these is having the more kinetic energy, so you'll say, ma'am, maybe gases. Why? Because students, the particles of our gases are always moving. So that is why student, they will have the more kinetic energy. Obviously, they will have the more kinetic energy, because student, it's just that kinetic energy, I have told you, it is that energy which develop when something in motion, and when something is very free to move, so that will have the more kinetic energy, and the one thing which is not able to move, so it will have the less kinetic energy. So in the case of the gases, the particles are very far apart, and even though they are freely movable, so that is why, student, in the case of the gases, the kinetic energy is more, but in the case of the liquid, it is less, because particles are close to each other somewhat, and in the case of the solid, it is like very less, very less kinetic energy, because what you can see, that the particles are so close to each other that they are not able to move here and there. That is why their kinetic energy is very less in the case of the solids. So that's the about the kinetic energy. Fine. Now if I talk about the temperature, that what will be the effect of temperature. Temperature means that, student, that I am heating all of these. So if the gases, if I'm heating it, so the particles will gain more energy and they will try to move more faster. In the case of the liquid, student, what will happen, that yes, they will again move faster, and in the case of the solid, student, they just vibrate at their position. So that's the point which I want to clear with you about the temperature and the kinetic energy. Okay. And see, student, if you apply the pressure over the gases particle, they will come closer and you will get the compressibility. But if you are applying the pressure over the solid, you will not get anything, because the particles are very close, they don't have any space to move, so that's why you don't get any compressible property in the case of solid. So these are the differences between these three states of matter, and these all are the properties which I want to discuss with you about the solid, liquid, and gases. And I hope you all are getting all of these points. Okay, good. You will say that, ma'am, appreciate that, I'm appreciating you. Okay. Now it's about the diffusion of gas. So student, as you can see that this container is having only blue color of particles initially. But when you have diffuse these pink color particles, so after some time you can see that these pink color particles are all over there. So that is the diffusion property of the gas, students, that the gases are having the diffusion properties. That means that the particles of the gases are that much far away from each other that any of the particle can diffuse in it. For example, students, how you will able to understand it, like in the kitchen your mother is cooking something very nice, like which you like the most, that even though from the smell of it you will get water in your mouth. Okay, I'm getting it right now. So what happened na, that the smell of that food is going to be, even though in the cartoons, like in the cartoons, I remember the Tom and Jerry cartoon. What happened, that there is one dog. Also, I don't remember that dog name. And so he was cooking something, and like a wave kind thing is coming over there to the nose of the Tom, and he want to go there so that he can eat it. So what's that thing, student? That the what I want to tell you is that the smell of the food, that the vapors of the food which we are getting from the cooking process, from heating it, we are getting the vapors. So those vapors are going to be diffused in the gases, because we know that the gases are having the space between it, so they will get dissolved in it. And by traveling through that part, like through that gases, so what will happen, that that smell reach to our nose, and that's how we can smell it, and we'll come to know that yes, there is something like something nice is going to be cooked and we are getting like something nice to eat. So that's the diffusion of gas, student, because gas are having particles which are very far away. They are having so much of spaces that the particles of other substance will get diffused very easily. So that is our, student, it's the property of the gases that which shows the diffusion. Even though in the atmosphere all of the gases are diffused with each other. Okay, so we'll see this video also.
In this lesson, we are going to learn about diffusion of gases. This will help you to understand how gases behave and also explain why smells spread. Before we start, you need to recall what solids, liquids and gases are like in terms of their particles. In particular, I'd like you to ask yourself, how are the particles arranged in a gas? Pause the video and restart it when you think you have the answer.
So you have
The
answer now?
answer is the particles in a gas are spaced out and move about very quickly in random directions. Did you get it right? This, of course, explains why a gas takes the shape of its container.
So students, like he is able to show you that the particles are very far apart from each other in the case of the gases, that they have so much of space, and even though they are occupying whole of the structure of that container. Exactly. That is why the gases particles are having very less force of attraction between these particles. They have very space between between the particles, and even though they don't have any fixed shape and volume. Okay.
It's because the particles will each continue to travel in a straight line until they hit something, in this case the wall of the container. So, the smelly gases given off by rotting vegetables in a sealed box will fill the box with rotting vegetable smell, but you won't be able to smell them outside the box. However, take the lid off the box and those particles will no longer bounce off the lid and be contained. They will start to escape into the air around the box.
See, student, from this thing, what I remember now, like one day, like when I was in a school, so what happened now that in our school that sometimes we feel to eat lunch. So what happened now that I like me and my friend was trying to eat lunch. Okay, don't do that, please don't do that. It's just that I'm sharing my experience to you. So what happened that my lunchbox, so I don't remember that what I was having in that day in my lunchbox, but I was feeling very hungry and I want to eat something, and the teacher was teaching us. Okay, so it's just that, and the teacher was of the subject maybe mathematics. Okay, and you know that the mathematics teachers are very strict kind of teacher, and he was a okay, yeah, he was a male teacher. So what happened that I opened the box, and what happened after just 2 minutes, he was like someone is eating food, someone has opened his lunch box or her lunch box. So I was like, oh like, oh my god, he came to know that yes that I have opened the lunch box. So how he came to know about this thing? Because student, that the smell of my food which is present inside the box when I have opened it, so what will happen that the smell of the food, like in this case, that these particles dissolve into the air, and that's how they all of the air smelling same. So that's the reason, student, that the smell of the food got dissolved into the air, diffused in the air, and that's how he that smell reaches to the nose of my teacher. And when he smelled it and he came to know, okay, that someone has opened up his lunch. So that's the you can say that the disadvantage also in some cases, that it got diffused. But yeah, in some cases it is also very helpful. Like if any places, some like if anything is that like you can say that if there is any electrical appliance which got burned or like which is heating, so what will happen now, we get the smell that yes, something is getting burned. So that we have to check, okay, what is going on. And we find out, okay, that if one electrical appliance is getting electric spark or something like that, so we can just stop it. Okay, so yes, we can say that in some cases the diffusion process of gas is very advantageous, and in some cases it is also having disadvantages, like in my case. So he came to know. So that is why, student, it's the property of gases that the particles are having space and they got diffused, and that's how we feel smell or something like that.
Soon notice the effect and will be able to smell the rotting vegetables. And that's those gas particles reaching your nose by diffusion. Diffusion is the random movement of one gas through another from a region of high concentration in this case inside the box, to a region of low concentration, in this case outside the box.
So see student, when the particles are present inside the box, so the smell is just in that box. But when I opened it, so from the high concentration, that means when the particles are more in that part, so they just go to the to the air, and after that, what will happen that the particles are very far apart from each other, and we call it as the low concentration. So the diffusion is the process in where when the particles move from the high concentration part to the low concentration part. Okay, and that's how the particles travel through the air and we get to smell each and everything. Okay, it's not like that very far I smell, no, but like if near to my room or near to my house, that's how. Okay.
It is a process that doesn't rely on wind or air currents. It will happen even if you are inside a building and the air is completely still. Now, there are many examples of diffusion, but smell is probably the most obvious one. These could be food smells, body smells from other people, the scent that a plant gives off to attract pollinating insects. And the same even applies with the smoke from a candle after it has been extinguished. It spreads out, and
So student, okay.
it's all due to diffusion. Now, here's a challenge for you. If someone walks into a room with some fresh flowers, why does it take a while for the smell of the flowers to fill the room? Why can't you smell them straight away? Pause the video, have a think, and restart it when you.
So what he was asking you that if you're having the fresh flowers and you put that fresh flower in the room, but you are not getting the smell of it at that particular time only. So what could be the reason of it? So just think about it. We'll see.
You think you have the answer. Well, just as the gas particles can hit the walls of a container and rebound, the particles can also hit each other. It doesn't matter if there is only a single gas or a mixture of gases. These collisions between particles are always taking place. It's very similar to trying to walk in a straight line through a busy crowd of people or a marketplace. It's very difficult to do without bumping shoulders with someone and changing direction. This explains why it takes a while for a smell to get from one part of a room to another. The high concentration of gas or smell particles takes time to spread out due to the collisions with the other gas particles in the air. And that is diffusion.
So yes, student, what he was telling that it will take some time so that it will move from the higher concentration to the lower concentration. That is why student we don't get the smell of the flower from one room to the another room at that particular time. Like but after some time, like after 5 minutes, 10 minutes, you will definitely get that smell. Okay, so it is because the particles of the like the particles of the gas or the particles of the smell of the flower will take some time to travel through the particles of the air, and that's how students it's the process of the diffusion is you can say that it is slow one. Okay, it's not like very fast, it is the slow one. For example student, even though when I apply the deodorant and after 2 minutes or 3 minutes 5 minutes when my sister was outside and she came to close to me, then she'll come to know that yes, I am applying, that I have applied some deodorant. Exactly, it's not like that she's sitting like something like in some another room and she's just getting the smell. It's not like that, but after some time definitely she will get some smell and she'll say that someone has applied the deodorant. So that is how the diffusion process is low, and the diffusion process which we see generally in the case of the gases only. Okay, because the rate of the diffusion in the case of gases is high. Okay, now see students, like I have talked to you that we have like only three states of matter: solid, liquid and gases. But student, what happened that after some time there were scientists who discovered the two other states of matter as well. One is the plasma and the another one is the Bose Einstein condensate, and these two are the states of matter which we don't find generally in our surroundings. Okay, so they you can say that then now in total we are having five states of matter. So the plasma is, you you can say it is not generally seen state of matter. It is that type of state of matter which consists of particles which are having very high, like very extreme kinetic energy, and due to which, student, we can see the sparkling, the lightning, because what happened that the that the electricity which we use, they ionize the gases, noble gases, and due to which we will able to see the plasma. For example, in the case of lightning, thundering, that is the state of matter which we called as the plasma. In that case, the particles are very extremely, that they, you can say that they are very highly movable, or you can say that they have extremely high kinetic energy. So that's the plasma. This is just for you, student, that it's not have something more about in it, that ma'am, why you are not explaining it in a very it like a very little bit, because student, plasma and the Bose Einstein condensate is very that kind of state of matter which we don't find out in our surrounding very much. Okay, and even though question has been asked over the solid, liquid and gases only, it's just that you should know that okay, we are having two other type of states of matter as well. Okay, and sometimes in the case of the Olympiads, the question can come that what's the fourth state of matter, or what's the fifth state of matter. So the solid, liquid and gases are the first three, but the fourth is plasma and the fifth is the Bose Einstein condensate. And this is that state of matter which we get when the gases are cooled to a very close, like very low temperature, like just generally to at very zero temperature. When we cool the gases at that temperature, we get that state of matter, and we called it as the Bose Einstein condensate. Okay, so students, like what we have just discussed till now, that what's the matter, the classification of matter, we come to know the properties of the liquid, solid, liquid and gases. We come to know that what's the difference between them. So student, in your exam, how the question can come, that they can ask you that what's the, like how the force of attraction differ in the solid, liquid and gases. So you will say that in the case of the solid, the particles are very compactly packed, due to which they have a very high force of attraction, and they are not compressible in nature. That's the reason for it. And in the case of the liquid, the particles are somewhat far apart, and in the case of the gases, they are very far apart and they have very less force of attraction, where you can say that in the case of gases it is negligible. So that's how, student, the question comes. And it's just that you have to remember that in the case of solid, particles are compactly packed. In liquid, they are somewhat far apart, they have a space between in it. But in the case of the gases, they are very far apart, they don't have any force of attraction, it is just negligible. So all these are the properties of solid, liquid and gases. And even though we have talked about the kinetic energy, we have talked about the pressure, that if I apply the pressure over the iron box, it is not going to be compressed. But if I apply the pressure over the gaseous particles, so they will come closer to each other, and that's how we get the another state of matter. Exactly. Even in the case of the temperature, if I'm heating the gaseous particles, so they will gain the heat and they will try to move more faster. That means the kinetic energy increases with increase in temperature for the gases. But if we talk about the solid, so the kinetic energy will be less, because particles are very close, they don't find any space to move. Even though when I give the heat or temperature is there, so what will happen, they just vibrate at their mean position. That is why the solids are rigid, whereas liquid and gases are having the fluidity, that means they can flow. So that's the point, student, which we have to discuss today. Okay, now just discuss some of the questions here. What is the general name of rigid form of matter, fluid form of matter? So it's very easy, we have just discussed it right now, that the rigid form of matter, that means which cannot flow, is the solid one. And the fluid, that means which can flow, it is the liquid, and gas is the fluid form of water. Which of the two diffuses slower, bromine vapor into air or copper sulfate into water? So, my dear student, if I tell you that from here, from for this question, that the bromine vapors, that the bromine is in the present in the form of the vapors in the air, and you can say this vapor are going to be diffused into the air. But if I talk about copper sulfate, that the copper sulfate, it's CuSO4 and it is solid in nature, and this solid is going to be dissolved into the water. So which will be the faster, like which will diffuse slower, which will diffuse slower, students? Slower as compared to bromine vapor in air, because the rate of diffusion is faster in gases. Exactly, the rate of diffusion in the case of the gases is faster because they have very like a space between them, so that they will, that the other gas can dissolve or diffuse in it very easily. Whereas the student, what happened in the case of copper sulfate, it is the solid one, so it will take time to get distribute into the particles and to get dissolved into the water. To get the rate of diffusion higher in the case of this condition, when solid is dissolving into water, what we can do, student, like if you remember from this that the sugar solution also, when we add sugar, so they are present in the form of the crystals, that is the solid one only. So what we do to dissolve them more, like at the faster rate, we stir it. Exactly, we just stir it at a very high like at very high rate, so that the particles of the solid or not it is going to, sorry, the particles of the sugar is going to be dissolved into the water. Okay, because if I just, what you can do, student, you can do one experiment, take 2 glass of water, add one spoon of sugar into it. Okay, and do one thing, that kept one of the glass as it is, and in the another glass start stirring it. So what you'll see, that the in the glass in which you are stirring it, so you will see that the particles, that or the sugar crystal, are going to be dissolved very easily. But if you talk about that glass which is having the sugar crystals, in which you are not stirring it, so what you find out, that the sugar particles will remain as it is for some time, and it will start dissolving at a very like very slowly. That is why, student, we say in that the solids are having the very less rate of diffusion, whereas in the case of the gases, the rate of diffusion is very high. That is why, student, copper sulfate diffuses slower, because copper sulfate is solid, okay, as compared to the bromine vapor. Okay. Oh my God. So we have done this. So yes, students, I hope you get each and everything in this session. You'll come, like you must come to know about all of these properties, and you can solve more and more question over it. And even though, student, if you find any difficulty, or if any query or any question comes in your mind, and you can post your question over the forum, on public forum or on private forum, depending upon your conditions. So, and you'll get the answer, and that's how you'll be perfect about this chapter, and you can solve any question, and you'll get good marks. Okay, so we'll meet in our next session. Till then, keep learning from Ask IITians. Thank you.